Hello guys, welcome to DTW Tutorials. Welcome. So today's video is about the chemistry theory prep question solved from your WAEC 2020 chemistry past questions. Okay, so in this video you have the theory question solved. There's already a video on the OBJ 50 OBJ question solved on WAEC 2020 chemistry past questions. So this is to help you in your forthcoming NECO exams and also your WAEC exams. Okay, that's your WATs for Liberia, Ghana, Gambia, Sierra Leone, and Nigeria. Okay, so this is the theory. The chemistry is already on the channel, but I'm also going to leave the link to the objectives. Okay, the solution to the objectives of last year. I'm also going to leave the link in the video description box of this particular video. Okay, so this will support you in your chemistry exam to ensure you pass your exam. There's also the maths. There's also the maths already done for your 2020 maths past questions solved and explained. That's your OBJ. By God's grace, I'll try to do the theory and also upload. But I've already done the theory before. That's I think is it 2019 prep theory. In fact, I'm going to drop the link to the playlist of all WAEC past questions solved and explained. There's also that of physics. I'll drop and also English. I'm going to drop everything in the playlist so you watch. Okay, and it helps you in your forthcoming exam. So please try to subscribe to this channel. Okay, share this video with your friends, family, and loved ones preparing for the WAEC exam, and also give this video a thumbs up as it helps us helps DTW Tutorials to promote it on YouTube. Okay, so it reaches more people. Okay, so please subscribe, like, and share. And please, this video is not for sale. Please don't commercialize this. As I've done this freely, please also share freely. All right, so which other thing? Okay, I think I also want to introduce some few things. There's the DTW Tutorials blog. Okay, I'm gonna leave the DTW. I'm gonna put it on the screen right now. DTWtutorials.com. Okay, so there you would find your WAEC syllabus if you still don't have it to download freely, and other resources. There you will find your chemistry notes, your physics notes on each topic, and after the explanation of the notes you see past questions under those topics, okay, to help you prep for your exam. And also these are resources on the blog. You need to just go around the blog and you see several educational resources for you. Okay, and also if you have junior ones preparing for their BEC exams, junior WAEC exams, or their common entrance into secondary school exams, there's a new YouTube channel I've separated that is called DTW Tutorials. After the tutorials, just put a junior. While you search for it on YouTube, you go on YouTube, search for DTW Tutorials Junior. There on that channel you see a lot of videos that can help your siblings. If you have anyone siblings preparing for their junior WAEC in their primary school SAT common entrance exams, so there are videos there that would support them in their exam. And also, which other thing? Okay, and also finally to introduce you to DTW Educational Consult. All right, where we help students. We help them to study abroad in Ukraine, Russia, Belarus universities. Okay, this all you just require is just your WAEC. You don't need any other exam. You don't need any English exam. You don't need IETLS exams. You don't need TOEFL exams. No exam, just your WAEC. Okay, and to pay your school fees. Okay, that's all you need to study in Ukrainian universities, Russian universities, and Belarus universities. And we do this. We send students abroad, so we can consult for you. The processes take you through getting your admission and advising you for your visa, processing and all. Okay, so if you're interested in that, I'll also leave my email in the video description box of this video to contact me, and I'll also leave a link okay, to a blog post where you can read everything about it and also contact me if you have further questions. Okay, so not to take too long into this video. All right, so don't forget also that Jesus Christ is coming soon. Give your life to Christ, for he's the way, he's the truth, and he's the life, and he's the one who's going to lead you to heaven at last. All right, I also remembered something. There's a WAEC Facebook group. There's a Facebook group. I will leave the link to the video. I'll leave the link in the video description box of this video to the Facebook group for you to join. All right, so thank you from DTW Tutorials. Don't forget that you are destined to win. All right, so let's get on to the video now.
Okay, this is WAEC 2020 Chemistry Theory Question 1A. That's I and II. I says state Faraday's first law of electrolysis. II states distinguish between a strong electrolyte and a weak electrolyte. You know that Faraday has two laws of electrolysis. An electrolysis is the chemical decomposition of a substance that is in molten form or solution form by passing electric current through that substance. Okay, so Faraday's first law states that the amount of a substance that is discharged from an electrode in an electrolytic cell, okay, for electrolysis to take place, you have your electrolyte, you have your electrode, and you have your power source, your battery, for instance, where your current is coming from. Okay, so Faraday's first law is saying that the amount of substance that is discharged at the electrode, that is anode or cathode, either hydrogen or chlorine, whatever substance discharged here, the amount of that substance is directly proportional to the quantity of electricity that is passed through the electrolyte. So for Faraday's first law, we're talking about the substances discharged and what the quantity of electricity passing through the electrolyte. II says distinguish between a strong electrolyte and a weak electrolyte. Okay, so a strong electrolyte ionizes completely in water. That means they totally dissociate. Take for instance, you have sodium chloride. When this dissolves in water, this is your common salt. Okay, remember your electrolyte has to be in what? A molten form or solution form for it to be able to used in the electrolysis process. So this, when this dissolves in water, you have sodium chloride, sodium ion, and what? Chlorine ion. They're dissociating completely. Cl minus, Na plus, Cl minus. Okay, so strong electrolyte dissociates completely in your aqueous solution, while weak electrolyte ionizes partially or dissociates partially in an aqueous solution. Question 1A states 1B states one chemical property of ethine. Okay, so we know that ethine is an unsaturated hydrocarbon with triple bond, the simplest unsaturated hydrocarbon with triple bond. So you have this, the structural formula of ethine having a molecular formula of C2H2. Triple bond here makes it unsaturated hydrocarbon. So one chemical properties of ethine is that it burns in air. Okay, physical property is that it is a colorless gas. That's one physical properties of ethine. It's a colorless gas. Okay, but chemical property, it burns in air. You know when we say when something burns in air, that means it is reacting with what? Oxygen. This is ethine here reacting with oxygen to give you 4 moles of carbon dioxide and water. Okay, this is one chemical property. It burns in air. Another property is that it undergoes addition reaction. When you react an alkyne, okay, in an addition reaction, you get an alkane. Okay, so the principal reaction of the alkynes is addition across the triple bond to form alkanes. So this is a chemical property of ethine. Question 1B for WAEC 2020 Chemistry Theory Question. Question 1C. What is meant by the term unsaturated hydrocarbon? Okay, we explained that in 1B already. We said that unsaturated hydrocarbons, example is the ethine. Okay, they have double and triple bonds. So hydrocarbons are divided into saturated hydrocarbons, unsaturated, and you have your aromatic hydrocarbons. That's the benzene family. Okay, your unsaturated hydrocarbons, they have double or triple bond between their carbon atom. So you have ethane. Ethene has double bond. Then you have ethyne as well, has triple bond between its carbon atom. Okay, but saturated hydrocarbon is alkane family. They have single bonds. So an unsaturated hydrocarbon has double or triple bonds between the carbon atom. Number 2, complete the following reaction equation. CH3COH plus this. So here you have CH3C. This gives us this. So when you complete the reaction, this is what you get from this. So this CH3 displaces hydrogen here in the reaction. You see, an hydrogen joins this one to form molecule of water. So you have CH3COO here. This CH3 displaces hydrogen here. Then this reacts here to get what? Water. Okay, so name the major products formed in the reaction. Methyl ethanoate. This is methyl ethanoate, and that's the name of the product that we get. Question 1D. State one way by which the rate of esterification could be increased. So esterification is a reaction between an ethanoic acid, an alkanoic acid, and an alkanol. So reaction between an alkanoic acid and an alkanol to give us esters and water. This is an esterification reaction. For example of an alkanoic acid, you have your ethanoic. Remember the reaction we just solved now. Ethanoic acid in question 1C with an methanol to give us an ester. That was methyl ethanoate. Okay, so CH3COO. I told you this CH3 displaces hydrogen here plus to give you water. The H here and this OH here forms water. So this is an ester, this is an alkanoic, an alkanol to give you an ester. So this reaction is called an esterification reaction. So we can increase the rate of these by adding concentrated H2SO4 to your reaction. Or if you increase the concentration of this and this, the alkanoic acid and the alkanol, the rate at which esterification, that's your ester, is produced is increased. So this is ways in which we can increase the rate of esterification. Question 1E. Consider the reaction represented by the following equation. Zinc reacting with hydrochloric tetrasulfate 6 acid to give you zinc sulfate and hydrogen gas is liberated. So if 3.75 of zinc dust was added to excess tetrasulfate 6 acid, calculate the number of moles of hydrogen gas. So to do this, well, equation of reaction here is saying 1 mole of zinc. You can say that 1 mole of zinc liberates what? 1 mole of hydrogen gas. Now using these two because that is what is in zinc and hydrogen gas. So 1 mole of zinc here from the reaction, right, liberates what? 1 mole of hydrogen gas. And we know that from Avogadro's law constant, 1 mole of this is 6.02 times 10 raised to the power 23. Now 1 mole of zinc, what's the mass of zinc? 65.0 gram. Okay, so this is telling us that 65.0 gram of zinc, okay, reacting gives us 6.02 times 10 raised to the power 23 moles of what? Hydrogen gas. Okay, so but in the question they said 3.75. What will 3.75 zinc does give us? What number of hydrogen gas, number of molecules of hydrogen gas will that give? So this is what? X. So if you cross multiply, okay, you have 3.75 times 6.02 times 10 raised to the power 23 all over 65.0 because X is what? Standing on its own. So when you punch your calculator here, you get 3.47 times 10 raised to the power 23. So the answer to this is 3.47 times 10 raised to the power 23 molecules of hydrogen gas. 1F states the effects of global warming. We know global warming is the gradual heating of the Earth's surfaces, the ocean, the atmosphere by human activities like burning of fossil fuel, emitting and release of greenhouse gases to the atmosphere. Okay, so effects of global warming, we have the sea level rising, we have severe climate changes, we have drought, we have depletion of coral reefs, and coral reefs are underwater structures of skeletons of invertebrates, marine invertebrates. Okay, so these are the effects of global warming. Global warming is caused by burning of fossil fuels and the rest. This is the effect. Sea level is rising continuously. We have severe climate changes, we have severe drought and depletion of coral reefs. Question 1G. Consider the following reaction equation A, B, and C. Which of these equations represents a redox process? We know redox means reduction and oxidation. So it's an equation in which both reduction and oxidation is occurring at the same time. For this type of reaction, reduction is the gain of electrons, while oxidation is the loss of electrons. Right? So if you see option equation B, okay, hydrogen reacting with C2H4 to give you C2H6. Okay, here this is the redox reaction because both oxidation and reduction is occurring at the same time. Question 2 says state the change in oxidation number of the species that are oxidized or reduced. Now here H changes from 0. The oxidation state of H here is 0. Here it is -1, while that of carbon here changes from +2 here to +3. Now, oxidation is the loss of electron. Okay, so here oxidation is occurring here, carbon changing from +2 to +3 because it is losing more electron. Okay, it was losing 2 before, now it's now losing 3. So oxidation is occurring here from what? Carbon here, oxidation. Carbon here is what? Is undergoing oxidation. That means carbon is the reducing agent. The substance undergoes oxidation is the reducing agent. While here, hydrogen, gain of electron. Okay, gain of electron. So hydrogen here from 0 to -1 is what? Is gaining electron. So this is gaining, it is undergoing reduction. And the substance undergoing reduction is the oxidizing agent. So here our hydrogen is the oxidizing agent while our carbon is the reducing agent because it is undergoing oxidation and this one here is undergoing reduction. 1H states 2 of the main concepts of Bohr's model of the atom and 2 state the limitation of Bohr's model. So Bohr's model states looks like this. It says that an atom has a dense nucleus with the electrons revolving around orbitals around this nucleus. Okay, that's what Bohr's model is about. Okay, so the two main concepts of this is that electron in an atom revolve in circular orbits. This orbit here. Okay, they revolve in what? Circular orbits. Okay, another concept is that energy of an electron has a fixed value. Energy of an electron has a fixed value. Also, an electron emits energy in form of radiation when it moves from a higher energy level state to a lower energy state. Okay, so the limitation of Bohr's model is that it cannot explain for more complicated spectral lines observed in other spectra other than that of hydrogen. So when Bohr was using calculating this model, he used hydrogen as a case study. Okay, but Bohr's model cannot explain more complicated spectral lines observed in other spectra other than that of hydrogen. So that's the limitation of Bohr's model. 1I says list 3 factors that could influence the equilibrium position of a reversible reaction. We know equilibrium is attained when the rate of forward reaction equals the rate of backward reaction. It is represented by this arrow, forward and backward reaction. Okay, so for a reaction to be said to be at equilibrium, okay, different factors could influence this equilibrium position, because these factors can either make the equilibrium favor forward reaction or backward reaction. So these factors could be temperature, increasing or decreasing the temperature of the reactant could favor forward or backward reaction, increasing or decreasing the pressure and volume, as well as concentration of the reactant. So these three factors could influence the position of the reversible reaction of the equilibrium position, either forward or backward. So temperature, pressure, or volume, then concentration. This influence equilibrium position of a reversible reaction. 1J, calcium triazocarbonate 4 powder is added to separate equimolar solutions of hydrochloric acid and ethanoic acid. What's the similarity and what's the difference? So we are saying calcium triazocarbonate 4 is added to hydrochloric acid and ethanoic acid. So what's the similarity? Number one, the similarity is that they both produce a gas, and that is carbon dioxide. Okay, that's the similarity. They both, when you react this calcium triazocarbonate 4 and hydrochloric acid, or you also react the same calcium triazocarbonate 4 and ethanoic acid, they will both produce a gas, and that's the similarity. The gas is carbon dioxide. The difference is that HCl would produce a more vigorous reaction, whereas ethanoic acid produces a less vigorous reaction. So this one produces more vigorous reaction, while ethanoic produces a less vigorous reaction. Question 2, WAEC 2020 theory question. So consider the following compounds. What's the relationship between compound A and B? Give the name of compound A and B, and will the properties, chemical properties of compound A and B be the same, and give your reason for saying your answer. So this compound A and B are cis-trans isomers. They are stereoisomers, okay, with the same formula, but their functional groups are different. Functional groups are being rearranged, okay. The orientation are being rearranged in a three-dimensional space, okay, but they are cis-trans isomers. They're also called geometrical isomers or stereoisomers. That's the relationship between these. So if you can see, they have the same formula, but their functional groups are different. They are being rearranged. So here you have Cl and H. Here you have HCl. So when you just invert this, you have the same thing. The others are what? Exactly the same. Okay, so that's why we call them cis-trans isomers. What's the name of the compound? A is called trans 1,2-dichloroethene. Ethene because it's a double bond, right? 2 carbon atom, ethene. So trans 1,2-dichloroethene. Compound B is cis 1,2-dichloroethene. Okay, trans and cis, that's why they are also called cis-trans isomers. 3 says, will the chemical properties of the compounds A and B be the same? Yes. Remember I said that they have the same formula, just their functional groups orientation is different. So yes, they will have the same chemical properties. Give our reason is because they have the same type of atom connected in the same way. Okay, they both have the same type of atom, the same number of carbon, the same number of hydrogen, the same number of chlorine. It's just their arrangement, their orientation, and that is different. That is why we are saying that their chemical properties would still be the same. Question 2b. Give 2 characteristic features of boiling. What would be the effect of boiling water when you add crystals of sodium chloride to boiling water, and when you also reduce the atmospheric pressure? And 3 says, state one way in which evaporation differs from boiling. Okay, so characteristic features of boiling. Boiling takes place at a specific temperature. Boiling point of water is 100 degrees Celsius. So boiling takes place at a specific temperature. That's one feature. Another one is that it takes place throughout the liquid. Okay, and bubbles are formed. So boiling takes place throughout the liquid, and bubbles also are formed. When your water starts boiling, you see bubbles. That's a characteristic feature. What will be the effect of the following condition on boiling water when you add crystals of sodium chloride? So when you add sodium chloride, the boiling point increases. Okay, and also when you reduce atmospheric pressure of the boiling water, it also lowers the boiling point. Okay, so addition of sodium chloride increases the boiling point of water, while reduction of atmospheric pressure lowers the boiling point of water. That is 1B. So for III, they said difference between boiling and evaporation. Okay, so boiling occurs throughout the liquid. We said that while evaporation occurs only at the surface of the liquid. Only at the surface of the liquid. When water is evaporating, molecules to the atmosphere, it occurs only at the surface, whereas boiling occurs throughout the liquid. Okay, then boiling occurs at a particular temperature. We said that 100 degrees Celsius for water. Okay, for evaporation, it takes place at all temperature, whether the weather is cold or the weather is hot, whatever the temperature is, evaporation takes place. So this is two major difference between boiling and evaporation. Question 2C, differentiate between an unsaturated solution and a saturated solution. II says states two ways by which a saturated solution can be made to dissolve more solutes. III says states one factor that could affect the solubility of a solid in a liquid. Okay, so an unsaturated solution dissolves more solutes at a particular temperature, while saturated solution cannot dissolve any more solutes at that temperature. So a saturated solution, you can keep on adding more solutes and it will keep on dissolving. But a solution is said to be saturated where more addition of solutes would not dissolve because it has gotten to its point of saturation. Okay, that's one difference. Another one is an unsaturated solution does not contain undissolved solutes because you can still keep on adding more and they will keep on dissolving. So there is no undissolved solute. But saturated solution contains undissolved solutes because when it has gotten to a point of saturation and you keep on adding more solutes, the solutes you're adding would no longer dissolve. So a saturated solution contains undissolved solutes at a particular temperature, while unsaturated solution does not contain undissolved solutes. That's question I. So II says state two ways by which a saturated solution could be made to dissolve more solutes. So by increasing the temperature. When you increase the temperature, okay, a saturated solution can dissolve more. Also, when you increase the volume, so if you add more water, you have a saturated salt water solution, for instance, and you keep on adding more salt and it's no longer dissolving. That's because that water has gotten to its point of saturation. Okay, so if you want it to be able to dissolve more salt, you add what? Add more water. So when you increase the volume of the solvent, okay, you can add what? More salt and it will dissolve. Okay, also when you increase the temperature, okay, you can add more solute and it will also dissolve. So this is two ways in which you can make a saturated solution dissolve more solutes. Number 3 says state one factor that could affect the solubility of a solid in a liquid. Okay, how soluble a solid is in a liquid can be affected by several factors. The temperature, okay, the nature of the solutes, is it solid, okay, is it liquid, is it gas, the surface tension, how rough or brittle that solid is, determines the volume of the solvent. Is the solvent small? The quantity, is it more? That affects the solubility. The nature of the solvent as well. Is it a polar solvent or a non-polar solvent? All these are factors that affect the solubility of a solid in a liquid. Question 2D. Define the term mole. Consider the following reaction equation. What's the mass? Magnesium oxide reacting with hydrochloric acid to give you magnesium chloride plus water. What mass of magnesium oxide is needed to neutralize 25.0 cm cube of 0.1 mole dm cube of hydrochloric acid? So here we know that mole is a unit of measurement for calculating the amount of substance that is contained, and that substance can be an atom or a molecule. Okay, so here the concise definition is mole is the amount of substance containing 6.02 times 10 raised to the power 23 particles of that substance, containing as many elementary particles as there are in carbon 12 gram of carbon 12 isotope. So carbon 12 is a standard used in measuring the amount of mole, the number of mole of a substance. Okay, so that's question 1. Define the term mole. Then number 2, consider this reaction. We are asked to calculate the mass of magnesium oxide in this. So here, let's move on to calculate this. From the reaction here, you can see that the number of moles of magnesium oxide reacting here is 1. So number of moles of magnesium oxide is 1. While number of moles of hydrochloric acid here is 2. Number of moles of hydrochloric acid here is what? Is 2. Okay, now molar mass. We know molar mass of a compound is adding the individual masses of the reacting element. So here the molar mass of magnesium oxide, magnesium here is what? 24, has a mass of 24. Oxygen has a mass of 16. So when you add this together, you have 40. You know that molar mass is measured in gram per mole units. Okay, so now, but the question is saying what is the mass of magnesium oxide that we use to neutralize this mole of hydrochloric acid. So the mass of magnesium oxide here is your number of moles 1/2 times here 2.5 times 10 raised to power minus 3 times your molar mass, that's 40. So when you punch your calculator here, you get 0.050 gram. So this here is the number, the mass of magnesium oxide that is needed to neutralize 25.0 cm cube of 0.1 mole per dm cube of hydrochloric acid. Question 2 is a state 3 physical properties of metal. Okay, so metal are malleable. That means they can be beaten into sheets. They are ductile, they can be drawn into wire. Okay, they are lustrous. Okay, that means they are shiny. They have high melting and boiling point. They are good conductors of heat and electricity. They also have high tensile strength. Okay, also they are sonorous. That means they make sounds when you hit them. So these are several physical properties of metal. Example of metal, you have your sodium, your zinc, your calcium, and the rest. These are physical properties of metal. Here, question 3. So in an equilibrium reaction, gases Q2 and L2 react, that's their diatomic, to form Ql. The energy content of the reactant is 100 kJ and that of the product is 54 kJ. The energy content of the activated complex is 210. Draw the energy profile, determine the activation energy and the enthalpy change, write a balance equation, and say if it is exothermic or endothermic, and give a reason for your answer. So now to draw energy profile, we know that we need the energy and the reaction pathway. Is energy versus reaction pathway. So let us draw that here. This is energy and it's in kilojoule per mole. Energy here is kilojoule per mole, and this is our reaction pathway. Okay, so from the values given to us, we're using that. So you have here 50, you have 54, you have 100, and you have 210. So let's start counting. 50, we can have 100 here. Then our activated complex, we have here 210. Okay, now so to draw the energy profile, okay, we have what? That of the product is 54 kilojoules. So we can just do a dotted line here. This is representing our product, 54 kilojoule. Okay, now the reactant is what? 100 kilojoule. That's the energy content. So from here, this is what our reaction starts. Reactant, right? And it peaks, okay, at 210 because that's our activated complex, and comes down there. Our product is at what? 54 kilojoule. Okay, so here is 50. So in between, let's put here as 50. Then here is 54 kilojoules. So our reactant here, 100 kilojoule, that's the energy content, goes up. Activated complex is 210. It peaks and product is what? Formed here at 54 kilojoules. So let's write our reactant. Here is what? Q2 and what? R2. Q2 and is reacting with what? R2. Our product here is what? 2Q. When you write the equation of the reaction, you will see Q2 reacting with R2, we get what? 2QR. This is our activated complex here, up here. Okay, this is where it peaks. So this is our energy profile for this. Okay, so that's number 1. Then II says determine the activation energy of the reaction. So activation energy here, to calculate that, is what the energy content of the activated complex, that's 210 kilojoule, minus the energy content of the reactant, that's 100. So this is what 110 kilojoule. Remember to put your units. Activation energy is energy content of the activated complex, that's 110, minus that of the reactant, you get 110 kilojoule. Okay, II says what's the enthalpy change, that's delta H of the reactant. Okay, so enthalpy change, delta H here, is what heat of product and minus heat of formation of the reactant. Okay, so now the product is what, we know that that's what energy content, that's 54 kilojoule, right, minus that of the reactant, and that is what, 100 kilojoule. Like this gives us minus 46 is equals to minus 46 kilojoule per mole. So it's negative, it has a negative H value. Okay, minus 46 kilojoule per mole. So that is AI and II. Okay, so to write a balance, let's move to the next slide. Yes, pretty full. Okay, so write a balanced chemical equation for the reaction. So here you have Q 2 moles here. This is, I told you the reaction is diatomic, just like O2 H2. So Q2 plus R2, okay, gives us what, 2Ql. So this is our equation of the reaction. So say IV says state whether the reaction is exothermic or endothermic. It is what, exothermic. Why do we say that? Because energy is what, giving off. Energy is giving off. Our delta H is negative. We got a negative value of minus 46 kilojoule per mole. That also tells us. And also because the energy of the product is lower than that of the reactant. The energy of the product 54, lower than that of the reactant 100 kilojoule. So all these clues makes us know that the reaction is exothermic. Energy is giving off, right? The delta H is negative, minus 46 kilojoule per mole, and the energy of the product 54 kilojoule is lower than that of the reactant 100 kilojoule. Question 3b, consider the following table. Write the configuration of these elements. State which one is a metal, one most likely to form a charge with of +3, one that belongs to group 7 of the periodic table, and the compound that will be formed between F and G. So here you have element F, element E having atomic number of 7. So E is nitrogen, because nitrogen has atomic number of 7. That's 2, 5. Configuration 1s2, 2s2, 2p3. You have fluorine, is atomic number 9. So that is 2, 7. 1s2, 2s2, 2p5. You have magnesium, that is G. Atomic number 12, that is 2, 8, 2. Then you have aluminium, atomic number of 13. So that's H, 2, 8, 3. I have the configuration here, 1s2, 2s2, 2p6, 3s2, and 3p1. Okay, so II says state the one that are metal. We know that magnesium and aluminium are metal. Okay, magnesium and aluminium are metal. So this is I element H and element G. H and G, element H and element G. Space here, element H and element G are metals. So II says which elements will most likely form ion with charge of +3. The answer is aluminium, Al3+, because when aluminium goes into a reaction, it loses these 3 electrons. So it forms an ion with what, this Al3+, that is aluminium here, H3+, aluminium is H. So I says which one belongs to group 7? Answer is element F. You can see here 2, 7. Fluorine belongs to group 7, halogens. The number of electrons in the outermost shell determines its group. So here group 7. So element F here, that's fluorine. Then IV says the formula of compound formed between F and G. F and G, that's fluorine and magnesium. So you get this GF2. That's the formula of the compound that will be formed. So that's for question 3b. The question 3c says define the term isotopy. Isotopy is the existence of an atom of the same element having the same atomic number but different mass number. The same atomic number, different mass number. So we have examples of elements like hydrogen, the same atomic number. You have 3 isotopes of hydrogen: protium, deuterium, and tritium. So here's here the same atomic number, different mass number. Okay, you have protium. This is protium. This is deuterium. They are all isotopes of hydrogen. This is tritium. You also have for carbon. You have carbon 12. You have carbon 13. You have carbon 14. Okay, so these are the same atomic number and different mass number. It has different mass number because the number of neutrons is different. Okay, so these are isotopes. Isotope is the existence of an atom with the same atomic number but different mass number. That's question 3c. Okay, 3d says name the 3 building blocks of matter. Okay, we know that the 3 building blocks of matter are atom, that's the smallest part of an element that can exist alone. Ions are atoms with a charge. Okay, then molecules, 2 or more atoms chemically combined together. So these are the 3 building blocks of matter: atoms, ions, and molecules. Question 4a, WAEC 2020 chemistry theory question. In the laboratory preparation of dry chlorine gas, state the reagents used, the drying agents used, the mode of collection, the equation showing the preparation of chlorine gas, and how chlorine reacts. So here, the reagents used is concentrated HCl and manganese dioxide or potassium manganate 7. Okay, so that's we can react sodium concentration HCl with this or with this. So that's the reagents used when you want to prepare dry chlorine in the lab. So the drying agents, we use concentrated tetrasulfate 6 as a drying agent. The mode of collection, we use downward delivery or upward displacement of air. So when you're preparing chlorine gas, the equation for reaction is this. Remember I said we can use HCl and this, or we use this and HCl as well. So this is the equation. 16 moles of hydrochloric acid reacts with this to give you 2 moles of manganese chloride with some potassium chloride, water, and chlorine gas. That's your dry chlorine gas. This one as well reacts. You also have your dry chlorine gas here. That's what we are looking for. Okay, so II says write an equation to show how chlorine reacts with hot concentrated sodium hydroxide. So when chlorine reacts with hot concentrated sodium hydroxide, you have your sodium chlorate ion, sodium chlorate here. So the oxidation state of chlorine here is 5. Okay, so sodium chlorate ion, this is the reaction to show chlorine reacting with hot concentrated sodium hydroxide. Question 4b. Name the main raw material used in the extraction of iron in the blast furnace. Write the equation of the reaction taking place in the blast furnace. What's the name given to the iron obtained directly from the blast furnace, and state why the iron in the blast furnace obtained has a relative low melting point. So the main reaction raw materials here is hematite, coke, limestone. Okay, that's the main raw material used for the extraction of iron. The equation of reaction is this. So you have carbon reacting with oxygen here. You have this here. So this is the equation of the reaction here to get our iron. Okay, so I say what's the name of the iron obtained? It's called pig iron. We have several types of iron: pig iron, cast iron, and the rest. So pig iron is the kind of iron obtained from blast furnace. Then IV says why does iron have a low melting point? It's because it contains impurities. Presence of impurities is why it has low melting point. Okay, 4C, WAEC 2020 chemistry theory question. So the following equation presents one of the reaction steps involved in the contact process. Here, Why is SO3 produced during the reaction, not dissolved directly in water to form H2SO4? So say why is H2SO4 tetrasulfate acid regarded as an heavy chemical? And III says state the property exhibited by tetrasulfate acid in each of the following reaction equation. So now the dissolution of SO3 in water is highly exothermic. That means gas is giving off. Mist of acid droplets would be formed. Okay, so that is why SO3 is produced and is not dissolved directly in water, because it is highly exothermic. Okay, it's giving off gas. SO3 gas is giving off. Okay, and mist of acid droplets would be formed. So why is H2SO4 regarded as a heavy chemical? It's because it's produced on a large scale, unlike fine chemicals. Okay, it's a heavy chemical. It's produced on a large scale. It is required by many industries as raw materials. Schools use it for practicals and the rest. It is in high demand by other industries. That's why it is a heavy chemical. That's the opposite of fine chemical. Okay, what's the property of tetrasulfate? Here it is acting as a displacement or precipitating agent, while here it is an oxidizing agent. That means it's undergoing reduction. The element undergoing reduction is the oxidizing agent. So here H2SO4 is the oxidizing agent, whereas here it is the displacement or precipitating agent here. So that's for question 4C. WAEC theory question. Question 4D says, write a balanced chemical equation for the reaction between propanol and sodium. So you know propanol is C3H7OH. This is the same thing, we just condensed here. 1, 2, 3, that's C3. 3 plus 2, 5 plus 2 here, 7, 8, 7. You have your OH plus sodium. So here, the reaction here gives us sodium propoxide. Hydrogen gas is given off. Okay, so if you react, let's say we remove propanol and put ethanol, the reaction will give us sodium hexoxide. Our hydrogen gas will still be given off. If it is butane, butanol, and sodium, you get sodium butoxide. Hydrogen gas is given off. So this is sodium propoxide. So this is the balanced chemical reaction between this and the name of the product formed. Question 5A said, name two gases that can be used to perform the fountain experiment. What is the aim of the fountain experiment, and describe briefly the fountain experiment. So example of gases, we have ammonia gas, hydrogen chloride gas, sulfur oxide. These are the gases that can be used to perform the fountain experiment. Okay, what is the aim? We use fountain experiment to demonstrate that some gases have high solubility in water. Example like ammonia, hydrogen chloride, and sulfur oxide. We use a fountain experiment to demonstrate that they have high solubility in water. Okay, so describe a fountain experiment. That's III. So you see a picture here of we're using ammonia. Okay, using ammonia to show the fountain experiment. So we have a flask fitted with a glass jet. Okay, it's filled with dry ammonia, okay, or any soluble gas. That's either hydrogen chloride or sulfur oxide. Then we inject water through the inlet into what? Into the flask. The flask has a dry ammonia gas already. We inject water through the inlet into the flask. Now this dissolves the ammonia gas and causes a fountain through the jet. The water you've injected will dissolve the ammonia or the hydrogen chloride or the sulfur oxide and cause a fountain through the jet. So this is how the fountain experiment works. You have a picture by the side here to show. Number 5B said, name two chemical industries and state three effects of a chemical industry on the community in which it is cited. So we have textile industries, you have pharmaceuticals, you have tannery, you have dyes, you have paint. All these are chemical industries. Okay, and the effects of this industry, we have pollution. When you cite any of these industries in a community, that community is prone to what? Be polluted, on air pollution, land, and the rest. You have, but also leads to development of that community. Okay, because of the presence of that industry, it leads to employment opportunities because people living in that industry, in that community, can get employment in the industry. It also improves the standard of living of the people. So these are effects of citing a chemical industry in a community. Number 5 C. WAEC 2020 chemistry question. So name 3 products of the destructive distillation of coal and give one use each of the product named. So we have coke, we have coal tar, you have coal gases, you have ammonia liquor. So these are products of destructive distillation of coal. We use coke for fuel as fuel. We use it in the production of water gas. We use coke to extract metals. We use coal tar to synthesize chemicals. We use it in tarring of wood. We use it in manufacture of explosives. Your coal tar, we use that as a fuel in the house and also in industries. Then ammonia liquor, we use that in producing fertilizer. Okay, so these are uses of these products of destructive distillation of coal. 5D, WAEC 2020 chemistry question. Name 2 substances responsible for hardness in water. State 2 methods for removing hardness of water and state 2 the advantages of hard water. Okay, so the substance responsible for hardness of water is calcium hydrogen triazocarbonate 4 and calcium tetrazosulfate 4. So the presence of these substances in water is what makes water hard. The method, how do we remove hardness of water? We know we can remove temporal hardness by boiling, but when you have a permanent hard water, how do you remove that? You add calcium hydroxide. So adding calcium hydroxide to water removes what? Its hardness. When you also add washing soda crystals or use ion exchange resin, and there is exchange of ions, okay, these calcium ions are being removed. Okay, so these are methods in which you can remove hardness of water in water. Okay, so advantages of hard water. The calcium ion in water is good for children's teeth and bones, formation of teeth and bones, strengthening teeth and bones. Calcium ions is what is very, very, very good. So when you have water that has calcium ions, that water is automatically hard, but it helps in children's teeth and bones. Also produces exoskeleton of animals and shells. Okay, exoskeleton, that's outer skeletons of animals and shells. Okay, also provides calcium salts used in the manufacturing of food plants. So these are the advantages of hard water.
So thank you for staying tuned to the end of this video. Please don't forget to share, like, and subscribe to DTW Tutorials. You are destined to win.